Yeah, good evening, everyone. I hope you can hear me. Maybe we can wait a couple of minutes because I don't see people have joined. So, can you all hear me properly? Could you please confirm? Okay, fine. Yeah, thank you. Maybe 7:05, let us start. Okay. Yeah, thank you, Rahul. I hope you're all fine with whatever we have done till yesterday, right? Please keep practicing, otherwise you will tend to forget whatever you have learned. All right, it's 7:05, I think. So 7:04, maybe one more minute. Otherwise, practice book. How to use practice book? You mean that practice tables.sql file that is available to you? Yeah, we will see that. So I have shared a file called practice tables.sql, which contains all the tables that we will be using going forward. Right, so today we will get that loaded and we will use that for practicing purpose. I'll show you how to load it and you can use it. Right, first let us complete the DML part, because yesterday we saw up to update, right? Fine, let's start off. So yesterday we saw in the DML category, we have seen, right? In the DML category, we have seen updates, insert. We saw different ways in which we can do insert. By the way, DML stands for data manipulation, right? So data manipulation. So this is where we write data. Right, in the sense we can insert a record, add a completely new record into the table. You can make changes to a record that is already there in the table, and you can remove a record from the table, right? So this is what we mean by writing into the database or writing into the table, right? So that is what your DMLs are used for. See, I don't, so 1 second, let me just tell you, see all the PPTs, the learning material and all are controlled through ExcelR. So they will be sharing it with you in whatever manner they have been sharing till now, right? So I will not be personally sharing anything with you. The practice tables, all the material have been shared with you. And please limit your questions to whatever is happening in class, right? So questions about, attendance, chat, all those I am not responsible for it. So please, when you're in class, right, focus on what is happening in class, right? So don't think about the additional extra things, right? So that way we will not be able to complete our topic, right? I keep checking all the questions that you're asking and I try to answer all of them, right? So please limit it to the topic in hand, right? I hope you understand why I'm saying that. Right. So we have seen how to insert, how to update. So today we'll see how to delete a record from a table. Right. So deleting again. So I've opened the client, right, and I'm using the example DB. So these are the tables that we have in example DB. Right. Show tables. So yesterday we created 2 tables. I think today I have created a new table. I'll drop it. Drop table test. Okay, so these are the 2 tables we have been working with till now, right? So if you look at the contents of star from students, yesterday we had and the last thing that we had done was we had given a update command without a where clause, and that ended up updating all the rows, right? So that is where we had stopped yesterday. So today we need to see how to remove a record from the table. So just like we did for update, right? So we have to identify the main thing here is to identify correctly which record to delete, right? So if you write your where clause wrongly, you might end up deleting a record that you want to retain, right? So again, the where clause will tell you which record to delete. So if you say where student ID is equal to 3, then it means this is the record that we want to delete, right? So here all you need to do is you will say delete from students where student ID is equal to 3. So it will find the record for which student ID is equal to 3, and that record will be removed from your table. Right, this record will be deleted from your table. Right, so deleting, I think yesterday we saw the difference between deleting, dropping. Dropping is for tables or columns in a table. If you want to delete records, specific records, you have to go for delete, right? So when talking itself, you get into the habit of saying dropping a table and don't say deleting a table, right? So that way you will remember. So when you're talking about tables or columns, drop. When you're talking about records, use delete, right? So this will delete the record corresponding to student ID 3. You can give other conditions to identify, just like we did yesterday. I can say delete from students where student name is something, right? So if I say where student name is equal to, so where delete from students, where student name is equal to, let's say, Mary, then the second record will be deleted because this is the record for which the student name is Mary, right? So this record will get deleted from your table, right? See, deleting, the question here is, what if we want to delete a specific value and not the whole column? How, what exactly does that mean? How will it look like deleting a specific value? So the only thing you can do is if this is what you are meaning, right? If you want to remove this, the only option is you can make this null, right? So can you tell me what is this operation if I want to make this value to be equal to null? Right? You cannot delete a column, right? Alter, modify and all is for the structure of the table, right? When it, yeah, Uday, you are correct. You have to do update because this record already exists. So for an existing record, you are changing a particular value to null. So that is an update operation. So you can say update students, right? So set the value of course to be equal to null. Set course is equal to null, right? Where what is this? Student ID is equal to 1. Right? So that is why I keep insisting on the difference between tables, records, right, and columns. So any record that is already existing, any change you want to do, whether you want to make this null or something else, you have to go for an update operation only, right? Yeah, that is right. Somebody is saying every time I'm writing error code 1046, you can type one of the, you can paste one of the queries on the chat window. I can take a look at what is going wrong. Right. All right. So now let's try deleting a record. Right. What do we do? We will say delete from students. That's all we can do. Right. So no condition or nothing else here. And the where clause, which record to delete. Right. So I can say where student ID is equal to 1, in which case Jonathan will go off. I can use any other criteria. I can say where student name is equal to King. So now the last record will be removed from the table. I can say where marks is null. Now which records will go off? If I say where delete from students, where marks is null, it will find all records where the marks value is null, right? So there are 2 records for which mark is null. So both records will be deleted, right? Yeah. Okay. I don't know if, what's your name? Femin, I don't know how to pronounce. But see, select star from practice is the command that you have given, right? I don't know if you have a table called practice. If you have created a table called practice, then it will show whatever is inside it. And the second command is not show table, it is show tables, right? TABLES. Only then you will be able to see the result. So the syntax has to be typed exactly, right? Any small mistake in your syntax, you will get an error. All right, so let's try to delete, right? So first, let me try to delete student ID 2, right? So I will say delete from students where student ID is equal to 2, right? So now, no, let me delete 3. Student ID is equal to 3. So now Pete's record should be gone from the table, right? So here it says 1 row affected, which means 1 row has been removed from the table. So now if you try select star from students, you can see 3rd record is gone, right? So Pete's record is gone and we have only the seven records in the table. We had 8 rows, now we have only 7 rows in the table. Similarly, if I want to check delete based on the name column, right? So I mean, it's just another way of specifying which record, right? So I can say delete from students where student name is equal to King, for example, right? So now again, it says 1 row affected. So if you select from your tables, students, you can see King is gone, right? We have only 6 rows now. We don't have 7 rows anymore, right? So King is also gone from the table. Now let's try to delete all records where mark is null, right? So we can say delete from students where marks, remember, I cannot give marks is equal to null. This will not work, right? I cannot use any arithmetic operation with null. I have to say where marks is null, right? So this should remove 2 rows because there are 2 rows for which this condition is getting satisfied. For these 2 records, marks is null. So both records will be now deleted. So you can see 2 rows affected, right? If you check your tables, you can see 4, 5, 6, 7. 1 and 2 are gone, you don't have any records now where the mark value is null, right? Fine. So this is how it is done, right? So somebody is asking how to make it 1, 2, 3, 4. So what his question is, see, we removed 3 from here. Can we rearrange this so that you have 1, 2, 3, 4, right? So that is not a requirement at all. That's not a valid requirement because you will never do that. If you are very particular, you can find some way of doing it, right? It's not impossible to do, but it's not done. See, imagine, why do we have this ID column? The student ID or serial number or whatever it is used to uniquely identify a person, right? Let's say you have an employee table where you have employee ID as 100, 200, 300 and all, right? So these are 4 employees. So if somebody leaves the company, right? Employee 300 leaves the company, will the employee ID of everybody who's below them change? When people are leaving so every time people leave the company, everybody's employee ID will change, right? So this person will now become 300. This person will become 400, right? So that never happens. So it's not a valid requirement. It can be done, of course. You can select all the values below this and reassign it, but it's not done. There is no there is no one way to do it. And it's not a valid requirement also. Right, so there isn't any case where you will need such an update. Okay, right. So this is how you can write your delete command. Delete from tables and specify the where clause. Right, delete from students and specify the condition based on which you are deleting. Where, whatever condition. Right, so specify the condition. So this is one way to remove records. The other way, the next variation or the only variation that is available other than this is you say delete from students, right? But you don't specify the where clause. What happens when you don't specify a where clause? MySQL will by default assume that you want to apply this to all the records in the table. Remember our update where we didn't specify a where clause, right? Every record got updated. So here also, if you say delete from students and you forget to say, or you don't intentionally say the where condition, every record in the table will be removed, right? So let's try that. So if I say delete from students, where, sorry, no where clause, right? I just say delete from students. So now it says 4 rows affected. So all 4 students in the table have been removed. Right. So now if you say select star from students, it says empty set. There is nothing left inside your table. Right. So this is how you can use your delete command. Okay. Is this fine? So remember when we talked about DDL command, right? So when we talked about the DDL command, we had left off the, okay, let me insert some records into this table. Okay, so that I can show you. There was some insert, yeah. Okay, I've inserted 3 records into the table, right? So now if you select star from students, there are 3 records inside it, right? So when we talked about DDL, we had looked at 4 commands, but we left out one command, which is the truncate, right? So in the DDL category, we saw create. Remember our Dr. Cat commands? Create, alter, drop, then rename, right? So these we had already seen. One was remaining, right? So truncate was remaining. I said after looking at the DML commands, we'll come back to this, right? So here we have seen insert, update, and delete. So now that we are done with delete, we can come back to our truncate, right? If you see how truncate behaves, the way to write the command is you can just say truncate students. Right, so this will remove. Okay, let me say truncate, right? And let's see what is the result of this. So if I say truncate students, right? And if I say select star from students, you see you have an empty set, right? So there is nothing in the table. So it looks as if, yeah, it cleans the complete table. That is what it does, right? So if you see these two commands, when we said delete from students without giving any where clause, right? And we, oops, okay, that doesn't matter. So when we said delete from students without giving any where clause, and when you say truncate students, the result is the same, right? We get empty table. But remember, truncate is inside your DDL command, and DDL does not deal with any of the records, right? So DDL cannot, DDL is to do, it does not deal with the data, right? So this is only to deal with the structure of the table. So, but truncate, if you see, it looks as if it is removing the records from the table, right? It's removing the records from the table. So what truncate internally does is, truncate will execute two DDL commands. It will drop the table students and it will recreate the table students. Right, so when you drop, what happens? The table and all its contents are gone. Right, so truncate is equivalent to demolishing the house and the people inside it. Right, so house is gone, people, everybody is gone. And then again, it will say create the table, which means we are creating only the house back. We are not inserting any records into this. So what is the end result? End result is you have an empty house. Right, so we have an empty table. But on the other hand, when you say delete, right? So if you say delete from students without specifying a where clause, what we are doing is we are not touching the house, right? So we are asking everybody in the house to leave. So if there are 3 people in the house, we are asking all these 3 people to get out of the house. So what is the end result? You have an empty house, right? But there is a very big difference internally happening. Because when you say truncate, the table structure itself is deleted, dropped, and it's recreated. Whereas DDL command, delete, will only touch the records inside the table and not the structure of the table. Right, so this has a serious implication because any objects, later on, we will see you can create objects like views, then some sequence objects and all on top of a table. Right, so any object that you create on a table will also be gone if you do a truncate, because you are dropping the table itself, right? Whereas if you do a delete, any object like sequences, views and all created on a table will remain intact, right? So, so I hope the difference between yeah. So the difference between truncate and delete is clear, right? So delete from students without specifying the where clause and saying truncate students will both have the same end result. It looks as if it has the same end result. All the records are gone and you have an empty table, right? So here also you have an empty table. But truncate is a DDL command, and because internally it executes 2 DDL commands, one drop and one create, right? So this is truncate command, right? So I hope you are fine. So we are done with our DDL and DML commands. DDL is done, right? So five commands we saw. The doctor category, right? So data definition, where we had create to create a table, alter to make changes to the structure of the table, drop to drop a table from the database, table and everything from the database. Rename is to change the name of the table. And finally, truncate will drop and recreate the table, right? So end result is remove all the records or clean the table, right? So this will end up cleaning the table. Right, so these are the two categories of commands that we have seen. So the next and most important category is the DQL command. So there is only, so this is to read the contents of the table. Read in the sense we want to see what is inside the table. And what is the command we have been using? We have been using the select command. We have been using select star from tables, right? But that is just one way of using select. There are multiple ways in which we can use the select. There are a lot of, DQL stands for data query language. And it's used to see what is there inside the table. So there are many, many ways of using select. There are a lot of options in using select, which is what we are going to see today, right? So so you have been, I think, there is a table called practicetables.sql that has been shared with you, right? So we need to, so that contains the commands to create a few tables and to insert records into those tables, right? Let me open it and show you. So you need to get it loaded into your database. So how do you do that? Open your workbench, right? And then I'll show you how to do, right? If you're not able to do right now, you can watch the video and get it done, right? So you can open the workbench, say file, right? So you will see an option called open SQL script. So click on that. And now go to the place where you have downloaded that file, right? So wherever you have downloaded the practicetables.sql, right? You can just select it, right? And then say open. So here, if you see, you have create table commands, right? So create a table called authors and insert values into the table. Then there is a command to create a table called books and to insert values into it. Similarly, there is a command to create a table called drinks, right? Insert values into it. So like this, there are a set of tables. It basically contains code to create a set of tables and to insert records into it so that we can make use of those tables to learn the additional topics that we are going to look at, right? So open it, and in the very first line, say use example DB, right? Because this is the, or whatever database name you have given, say that, right? So you can type use followed by the name of your database, right? Add this line of code and then click on this icon, the third icon, right? Which will be directly above the use. Where it is shared, I'm not sure. Mukesh, probably you can help them with where the material is shared. Right, Mukesh, if you're there, could you please help them with that? Okay. Right. So do this, right? Add a line here and click on this lightning button, the third button. Don't select anything, right? So just click on this and you will see a set of commands are getting executed, right? So now if you go to your example DB and expand the tables, let me, if you don't see any additional tables here, click on the refresh button. Right, so now you can see a bunch of tables have been created under the example DB database. So these are the tables that we are going to be using for the rest of the sessions, right? So that we don't have to spend time creating and inserting records and all, right? Do get it done, right? If not right now, probably later you can watch the videos and load the data into your database. Right. So now if I come here and say show tables, I will see a bunch of tables. Right. So these are all the tables that we have just loaded. Right. So in order to work with our select command, I will be mainly using this table called myEMP. Right. So that contains details about different employees in a table. Right. So the simplest form of select that we have seen is select star from the name of the table, from my EMP, right? Semicolon, enter. So you can see there are 106 rows, right? And these are all the records that are available in the table. So this will show you everything that is there inside the table. Star basically means select all the columns in the table, right? So there are 10 columns in this particular table. So we are saying select all the columns from the table and show all the rows also, right? So, so if you're looking at a new table for the first time, right, you may not know how many records are there. Some tables will have millions of records, right? So there will be certain tables which have few records, thousands of records, or maybe hundreds, right? You don't have an idea about. Aditi is asking command to insert a record if it does not exist already. So we have seen the insert command, right? So we will say insert into table values followed by the values to be specified, right? We have seen that yesterday, different ways of inserting records. Yeah, count you can use, but we have not looked at count yet. But for the moment, right? If you are given a table called, if you're looking at a table that you're not familiar with, you have no idea like how many records are there and what are the columns inside it. So one way is, of course, you can say select count of star. We'll talk about count a little later when we talk about aggregate functions, right? So you can say select count of star from my EMP. So this will give you how many records are there in the table, right? So star basically you can think of count. Think of it as a record because we are it refers to all the columns in the table. So that is one way, right? But this will only tell you how many records are there. You will not be able to see what is the content of the table, what all values, what type of values are there, right? So in that case, what you can do is you can say select star from my EMP and you can give a limit option. You can say limit LIMIT, limit it to 10 records, for example. So this will show you the first 10 records in the table. Right, so this will give you an idea, right? You can see what all columns are there, column names are there, and what types of values are going into each of these columns, right? So this is a better way to take a peek into the table and understand what columns are there and what are the type of records that you have, right? So this is, yeah, it's similar to saying top, right? So in MySQL, you will say limit, right? So you will limit it to the first 10 records or first 5 records. How many ever you want to see, you can just specify that, right? I can say limit it to 5 records, right? So it will show me only the first 5 records. So we will keep using this limit, right? Because otherwise it will show all the 100 records which we are not interested in, right? So there is no top here. The option is limit, right? Limit 5 will show you the first 5 records. Okay, so this is one thing that you can use along with your select. So next option is we don't want to see all the columns, right? You are probably interested in only few of these columns. So you can say, I want to see the first name and last name of employees, and I want to see the job ID of them, right? So in that case, what you can do is you can say select and give the list of columns you want to see. You can say, show me the first name, the last name, then the job ID, right? What is his role and how much is his salary? So only these columns I am interested in, right? If you say star, by default, it will give you all the records. If you want to see only specific columns, you have to give a list of those columns that you are interested in. So I just want to see these 4 columns, right? So I will say select first name, last name, job ID, and salary from my EMP, right? Along with this, I can also use the limit command because I don't want to see all 106 records. It's not necessary to give limit, right? I'm just limiting it to the first 10 records. So here you can see only few columns will be taken from the database and it is shown. Yeah, MySQL is case insensitive. So column names, the contents of the columns, right? Everything you can give in short, small letters, capital letters, it doesn't matter. Uppercase, lowercase, it doesn't matter, right? Okay. So this is the second way of using your select. You can choose to have, you can only select a few of the columns from the table, right? So the third way of using select is you can select what are known as derived columns. Derived columns in the sense, even columns which are not there in the table, right? You might want to do some modifications on some columns which are available in your table, and you may want to see the modified values, right? For example, let us say every employee in the company is being given a bonus of some 10% or 15% or 20%, right? And you want to see what is the bonus amount for every employee, right? So in that case, what you can do, you can say something like this. You can say select, right? All of these terms, all of these columns. But along with that, you also want to know what is 20% of everybody's salary. So I can say salary star 0.2, right? So that will be 20% of the salary, right? So there is nothing called salary star 2 in the basic table. See, one thing you need to remember, select will not make any change to the backend table. Select is only for display purpose, right? So anything you are selecting here, it's only for display. Only for display. It will not make any change to the backend table. Nothing changes here. But here you can select this as if there is a column where you are calculating salary into 20%. Right. So now if you execute this, you will see salary is 24,000, but 20% of the salary is 4,800. Right. So this is the bonus that the person is going to get. So this person is Stephen King is going to get a bonus of 4,800. Meena Kochar is going to get a bonus of 3,400, right? Which is, how did we get it? We got it by multiplying salary by 0.2, right? So we have selected something as if it exists in the table, right? So this is called a derived column. You are making use of the existing columns, making some changes on it, and you are selecting as if it exists in the table. Can we perform same actions with characters also? Yes, you can perform, but only those actions which make sense for a character-based column, right? For example, you can do concatenation. You can attach first name and last name, right? Maybe you don't want to see this separately. You want to see Stephen King as one name. So in that case, you can take the same thing, right? And you can say concat, but you can only use functions which you can use on character type of data, right? So you can say concat, the first name, comma last name I can say, but if you do this, there will be no space between Stephen and King, right? If you do this, you can see Stephen King, Meena Kochar and all are coming attached on top of each other. So concat is basically to put attach two columns together, right? So not two, you can put together multiple things. So I can say something like this. If I want to make it more readable, I can say concat first name, right, comma, and then I want a space, then attach a space, and then attach the last name, right? So now I am concatenating three things together so that it looks better. So now it looks better, right? You have Stephen, and then a space, and then King, right? So that is what the concat operation will do. So now if you look at the column names, right? So the column name doesn't look very good, right? Because whatever you are typing here, exactly that is coming as the column name here. But this is not very nice, right? It's not good to look at. So what we can do is you can give what is known as an alias name for a column, right? So you can have a column alias. What is an alias name? It's just an alternate name, right? So alias is an alternate name for a column, right? So I can say, I want to call this as name, right? Or employee name. And I want to call this column as bonus, right? So I can give an alias name for this. I can say, select this as bonus, right? And select this value as name or employee name, right? So now instead of typing this big value as the column name, it will take this as the column name. Remember, we are not making any change in the backend, right? It's only for display purpose, right? So shall we try that? So I can say select this. By the way, the keyword as is kind of optional. I can directly say this as name, right? I don't have to specify as, but it's better to do that, right? It's a little more cleaner. It's a personal preference, right? So salary into 0.2 as bonus, or let me leave out as here, right? Because you can just say bonus. Either way you can say, you can use as or you can leave it out, right? So now if you look at the output, this is much more cleaner than this, right? Because we exactly know what it is that we are selecting here. What we have calculated here is the bonus, right? Instead of showing some formula here, we can give it an alias name, right? And it makes it cleaner to use. And also when you're writing some applications and all, this is much better if you can use an alias name. Fine. By the way, it is not necessary that you have to use alias names only on derived columns. I can change the name of a non-derived column also. Instead of job ID, right? Maybe I want to see call it role, right? I can do that. It's not necessary that it should be a derived column only, then you can use alias name, right? I can call this role. So you can just see, instead of job ID, this says role, right? So this is how you can use an alias name, right, in order to make the result or the output of the query look more readable, right? And it gives you more information also. It's cleaner, it's more readable, and it tells you exactly what it is that you're selecting, right? Fine. So the next thing that we will look at is how to find unique values in a column, right? So if you look at your my EMP table, you select star from my EMP and limit it to 5 records. You can see you have department ID 90, you have department ID 60, right? So like that, you have multiple departments. So there are many departments in the company, right? And you are interested in knowing what are the unique values inside it? What are the actual departments that are available, right? So if you say select department ID from my EMP, it will only show you the department IDs corresponding to every employee in the table, right? So how do you find unique values from this? You have to use the distinct keyword, right? You have to say select distinct department ID. Give me only the unique values from the department ID column from my EMP. So here you see there are 11 records. That means there are 11 departments in the table in the company. You have 10, 20, 30, 40 up to 110, right? So there are 11 departments or 11 unique values inside the department ID column, right? So distinct is the keyword that you need to use. Don't use any bracket or anything, right? Distinct followed by the name of the column, right? What if you have multiple values following? If I say distinct department ID, comma manager ID, what will happen? I am asking for unique department ID, comma manager ID. So whenever you specify multiple values, right, when you specify more than one column following distinct, then it means we are asking for a distinct combination of those. So if I say distinct department ID, comma manager ID, right? So then what I'm saying is give me a distinct combination of this. It's okay if department is repeated. It's okay if manager ID is repeated, right? But I don't want a repeated combination of department ID and manager ID. So I can have department 10, manager 101. Then you will get department 10 itself, manager 102 is there, right? And in department 20 also manager, the same manager is managing department 10 and 20. And in department 20, there is one more manager, 103. So although this is repeated and this is repeated, what is not repeated is the distinct combination of these, right? I hope you are fine with this. Let's take a smaller table, right? So we have a table called person on your database. So if you say select star from person, right? So you see only first name and last name. So if I say select distinct first name from person, what values will I get? If I say distinct first name, what all values will I get? Yeah, that's right. You will get John and Tom, right? So you'll get John and Tom. So these are the unique values. How about distinct L name? If I say distinct L name, last name, then I will get Perry, I will get Peters, I'll get England, and I'll get Cruz, right? Unique values from this column. But if I say distinct first name, comma last name, right? F name and last name, then what I will get is I will get a unique combination of this. So John and Peters, I will get this, John and Perry, I will get. John and Peters is a unique combination. John and England is a unique combination. Although John is repeated, this combination is unique, right? Similarly, Tom and England is a unique combination. Tom and Cruz is unique. This is repeated, this I will not get. John Peters is also being repeated, so this also I will not get. Right? So the result will be John Perry, John Peters, John England, Tom England, and Tom Cruise. Right? So this is what happens when you give multiple values following distinct. We are looking for a distinct combination. The combination of these two has to be unique. Right? Shall we try? So if I say select distinct first name, comma last name from person, I get these 4 rows, right? Let me clean it up. I'll get the these rows. Only distinct combination of these will be there. Tom Cruise and John Peters will not come because they already exist, right? So this combination already exists. Yeah, that's right, Aditi. All right. So this is what distinct would do. So distinct is used to find the unique values from a column, or if you want multiple columns, then you can use distinct to get a unique combination of values from different columns. This is applicable if you have n number of columns, right? If you have 3 values after distinct, right? If you're selecting distinct column 1, column 2, column 3, we are looking for a unique combination of column 1, column 2, column 3. Right. Right. So that is your distinct command. So now let us see how to sort our data, right? How to sort records based on different columns. Sort based on columns. Yeah, that's right. Sort based on columns, right? So we can change the order in which the records are displayed. So if I say select star from my EMP, right, the default order is the order in which the records are inserted into the table. Right, it looks like the employees have been inserted in order, right? Because the next employee who comes in, they will Lokesh is asking distinct will remove duplicates. It will, you can say that, right? But it will not delete from the table. It will not remove from the backend table. But the result that is shown to you will not contain duplicate values. So you cannot, it's not entirely correct to say it removes duplicates. For display purpose, yes, right? It removes all the duplicates and shows only the unique values. But the backend table remains unchanged. That you need to remember, right? Yeah. Okay, so here talking about ordering, the default order is the order in which the records are inserted, right? Here it looks as if it's ordered based on employee ID, but actually this is the order in which the records have been inserted into the table. So this order can be changed, right? I can arrange the records based on department ID, for example, or I can arrange it based on the alphabetical order of names, or I can arrange it based on the seniority, right? All those is possible. Yeah. So how do we do that? Let's arrange the records based on department ID. So that means people in department 10 will come first, right? So then people in department 20 will come. Then people from department 30 will come, right? So we want to change it in this order, not based on the employee ID order, right? So how do you do that? You just say select star from my EMP, order by order based on the department ID column, right? So now you see the records are jumbled, right? You don't see it in the correct order, not in the order of employee ID. But if you look at the department table, department ID column, you can see 10, then 20, then people from 30, then 40, then 50, right? So by default, it will arrange it in ascending order, the smallest number to the largest number. What if you want to change it? If you want to see it in descending order, you can just say order by department ID, DESC. DESC here stands for descending, right? So this will show the records in from highest number to the lowest number. So department 1, 10 will come on top and 10 will come at the very bottom, right? So you can see people in department 10 is here, 20, then 30, right? It's arranged in reverse order. 110, 100, 90, 80, right? So this is how you can change the ordering, right? If you want for ascending order, you can specify ASC, but it's not required. Whether you say it or not, it will automatically take it as ascending order, right? So there is a default ordering for different data types. So if you are using, if you have numeric column like your department ID, right? So if you are dealing with numeric columns, numbers, the default ordering or the ascending order is from lowest to the highest. If you have character type of column, the default ordering is in the alphabetical order. It will go from A to Z, right? If you have dates, if you have a date column, the default ordering is from the earliest date to the latest date. So this is what your ascending order is all about. This is the default ordering, right? If you say descending, of course, it will be in the reverse order, but it depends on the data type of the particular column, right? So if you want to arrange names in alphabetical order, I can just say, right? So select star from my EMP, order by, let's order it based on the last name, right? Order by last underscore name. So now you will see the records are arranged in alphabetical order. You can see Z at the very end, right? U, V, W, there is no XY, right? And the very first value is A, then B, then no C, C, then D, right? So this will, by default, the ordering for a character type of data is alphabetical order. You can obviously reverse it. You can say DESC, right? So this will, you can see A at the bottom and Z at the top, right? If you try it on higher date, what will happen? If you order based on higher date, then the earliest one will come on the top. The earliest date will come on the top. So you can see this person. So this is quite an old table, right? So that is why you see higher date and all in 1976, right? So this is, I think even your parents may not be born at this time, but they have so many years of experience, right? So this is the person who joined first in 1976. And if you see at the very end, this is the person who joined at the very end. They joined in 2019, right? So, so this is the default ordering for a date type of column. If you say descending, then the latest date will come on top and the earliest date will come at the bottom, right? Or the person with the least experience will be on top and the person with the most experience will be at the very bottom, right? So this is how you can order records in a table, right? And you can specify whether you want to order it in ascending or descending order, right? Okay, so now let us see how to use the where clause along with the select. We have used where clause along with our update and delete, right? We used it to identify the records. Where clause is the one which tells us which record we need to see, right? Which record needs to be modified. Lokesh is asking, by default, it will taking ascending. Yeah, by default, it is ascending. You don't specify anything, it is ascending. If you want it to be descending, you have to say DESC. Okay. Right. So coming to the where clause, the select command, till now, we have been looking at all the rows. Of course, we used limit, right, to how to get the last record in the table. You can order by descending and limit it to 1. Right? You can order the record in descending order and say limit 1. That will give you the very first record. Very last record. All right. What were we doing? Yeah, we were looking at the where clause in the select, right? So where, we know why do we use where? Where is used to identify which records. Identify records. After you identify the record, you can do whatever you want. You can do an update, you can do a delete, right? Or you can do a select. That is, we are saying only select those records which satisfy this where condition, right? So I can say, if I want to see only people from department 60, for example, I can say select star from my EMP. Now I will specify the where along with my select, right? I can say where department ID is equal to 60. So this will show me only those records where the department ID is 60. That is, only employees belonging to department 60 will be displayed. Okay. Shall we try it? So we'll say select star from my EMP, right? And where, now we specify a where clause, where department ID is equal to 60. So you see only those records belonging to people from department 60. You don't see any other records, right? Okay, so this is how you can use a where condition. So when you're writing a where condition, It's not just equal to that you can use. You can use, see, this applies to all where conditions, whether you are using it along with an update or a delete or a select. It's not only equal to, right? You can use a set of operators. For example, I can see all people who get a salary more than $10,000, for example, right? So what all operators can I use in my where clause? I can use equal to, like we did here, right? I can use greater than, I can use greater than or equal to, I can use less than or equal to. What else can I use? I can use then not equal to, right? Not equal to can be written in two ways. And then you have something called an in operator, and you have a between and operator. Right? Between and. So these are different operators that you can use when you are selecting records, right? So I can say select star from my EMP. Let me remove this. So I can say select star from my EMP where salary is greater than 10,000. Right? It will show only those records where the salary is greater than 10,000. Right? Then you can say greater than or equal to. So if you say greater than, it will not include people who get exactly 10,000. Right? If you want to include people who get 10,000 and above, you can say greater than or equal to. Right? Now you can see earlier there were 15 records. Now there are 19 records. Right? So that is because it has included 4 people who are getting exactly, who are getting exactly 10,000. You have one person here, 2, 3, and 4. Right? So these are the 4 additional rows where they are getting exactly 10,000. Right? So greater than or equal to means 10,000 and above. If you say greater than 10,000, 10,000 will not be included. Right? So similarly, you can use less than or equal to. Right? How do you use not equal to? If I want to see everyone except people in department 50, for example, right? So in that case, what I will do, select star from my EMP, where the department ID of a person is not equal to 80, right? So everyone except people from 80 will be displayed. So you can see, you don't see anybody from department 80 here, right? So that is your not equal to, yeah. Okay, now the between operator. Between is very convenient thing to use, right? You can say select star from my EMP where salary between 10,000 and 15,000. Sorry, 15,000, right? So this will show me all people whose salary is between 10,000 and 15,000, including 10,000 and 15,000, right? Inclusive of this. So this is very convenient thing to write, right? It's very easy to write it. It's more very English-like, right? So you can say where salary between this value and this value, or you can find all people who were employed within a particular period, right? So I can say everybody employed between 1st January 2000 and 31st December 2000. So everyone who was hired in the year 2000 will be displayed. Right? So there are other ways to do it, but this is also something that you can do. Right? It's a between operation. And then coming to the where clause again, till now we have given only one condition. Right? So we have seen people who have greater than 10,000. We have selected people who belong to department 80. What if I want to see, right, everyone in a particular department, let's say department 80, getting more than 10,000? So now I have to club two conditions, right? I want to see people from department 80, right, who are getting a salary greater than 10,000. So one condition is the department ID should be equal to 80. And the other condition is that salary has to be greater than 10,000. Only when both conditions are satisfied. Yeah, that's right. Only when both conditions are satisfied, we want to select a record. So there are two ways to club two conditions together, right? So you can use and, or you can use or. If you say and, only those records which satisfy both the conditions will be selected. If you say or, either this should be satisfied, right, or this should be satisfied. It's not necessary that both conditions have to be satisfied, right? So let's find everybody in department 80 getting more than 10,000. I don't know if there are anybody like that, but let's check it out, right? So I'll say select star from employee, my EMP, where where salary is greater than 10,000 and DPID is equal to 80. Right, so there are so many people, and if you look at every record, right, both conditions will be satisfied. This is true, right? So the salary is more than 10,000 and department ID is equal to 80. Both conditions are satisfied for every record that is selected, right? So that is what your and condition is all about. If you replace it with or, only one condition needs to be satisfied, right? So let's try that. So if I say or here instead of and, now what happens? See, if you look at this record, right, you can, if you look at this particular record, this condition is not satisfied, but it's selected because this condition is true. So only one of this needs to be true, right? So here also, this record has been selected because this condition is true, although this is false. Coming to this, this record, if you see, this was selected because this condition is true. Department is 80, but the salary is not greater than 10,000, right? But it's enough if one of the conditions is true. That is what your or is all about. Okay. Either one of the conditions should be satisfied, in which case you will be able to see the result. Those records will be selected. And finally, let us look at the in operation. So let's say I want to see all people belonging to departments 20, right, department 40 and department 80, right? So one way to do that is I can say select star from my EMP, where department ID is equal to 80, right? Or let's, what were the departments I wanted? 60. So if the department ID is 60, or if the department ID is 20, right? Or if the department ID is 40, right? I want to see these people, right? If the department ID is 60, 20, or 40, I want to see those, only those employees. Where is the error? Okay. Where department ID, right? So this is the command. So this is one way, right? So the other way is, instead of writing so many or conditions, right, I can use the in operator. If you're familiar with Python, then it's very similar to that, right? So I can say wherever the department ID happens to be in the following list, where department ID in 20, 40, 60, right? If the department ID of the person happens to be in this list, then select those records, right? So this will give you the same set of 8 rows that we saw there. But this is a more concise way of writing your query. right? So this is how you can write your in operator to select values. Right, so these are the different operators that you can use when you are using your select. And we have seen how to club two conditions, multiple conditions actually, right? Using either and or the or operator. Right, so next thing we need to see is how to use functions. How to use functions in your query. Right, so when it comes to functions, there are two types of functions that are supported in MySQL. You have what is called the row level function, right? You have a row level function, and you have what is known as a group function or an aggregate function. Group or aggregate function. What is a row level function? A row level function, by the way, a function is the same as a function in your Python or any other language. It will take a parameter, right, and it will give out a value. So let's say I have something like this. I have select. We used a concat function, right, which was used to put together multiple columns. Similarly, there are other functions which are available, right, depending upon the type of data on which it is used. So I can say select hire date and year of hire date from my EMP, and let me limit it to 10 records. Oops, limit 10, right? So this year is a function. So this is a row level function, right? So the year that you see here, this is a row level function. It takes hire date as a parameter and it returns one value. Right? A function is supposed to return a value and it can return only one value. Right? So in this case, it is taking this as input and I get one output for the first record. Then for the second record, it takes this as the input and it's giving me this output. By the way, what is it doing? It's taking out the year part from the date and giving us only the year of the date, right? From here, it is taking 1987 and it's returning us the year corresponding to that. So this for the third row, it takes this as input and we get one output. Fourth row, it takes this as input, you get this as output, right? For each row, one value for each row. So that is why this is a row level function, right? But there are certain functions where it doesn't make sense to give one value as an input. For example, if you want to find the sum of some values, you won't give one value and say find the sum, right? You need to give it a set of values, and for one set of values, it will give you one result, right? So for a row level function, one row, one value, one output, right? For a aggregate function, a set of rows, one output, right? So such a function is called an aggregate function. So in MySQL, there are 6 such aggregate functions. You can find the sum of a set of numbers. You can find the average of a set of numbers. You can find the minimum of a set of numbers. You can find the maximum of a set of numbers. You can find the count of a set of numbers. And you can find the standard deviation of a set of numbers. These are the 6 group functions that are supported in MySQL, right? So if I say select sum of, for example, salary, right, from my EMP, it will take all 106 salaries, add it up, and it will give me one output. Similarly, if I say select average salary from my EMP, it will take all 106 records as input. For this records, it will find the average and it will give me one output for the entire group, right? So that is why this is called a group function. Let's try it out. right? So let's say select sum of salary from my EMP. Right, so this is the total of all the salaries. Similarly, if I say average salary, it will give me the average of all these salaries, right? So basically sum of the salary divided by the total number of records. So this is the average salary of a person in this company, right? It's taken all 106 records and it's giving me one value as output. So if you want to see what is the minimum and maximum salary, also you can say min of salary, comma, max of salary, and the average salary, right, from my EMP. So you can see the minimum salary a person in the company gets is 2,100. The maximum salary is 24,000. And the average salary of a person in the company is around 6,456. Right? So this is what we mean by an aggregate function, a group function, which takes a set of records as input, and for each group, I get one output, right? But there will be cases where I don't want to see the average salary of the entire company. What if I want to know what is the average salary earned by a person in each department? I want an output like this. I want to get department ID and the average salary. That is, for a person in department 10, the average salary is 1,500. For somebody in department 20, the average salary is 2,000, right? Somebody in department 30, the average salary is 1,750 and so on. For each department, I want to find the average salary, right? So if you are asked to do this manually, right, what would you do? If you have to, Mukesh, the question here is how can we get the average of top 10 salaries? You can limit your records, right? And you can probably take the, no, you can't limit it. Thing is, there are, see, when you say the first 10 records or the first 20 records and all, we need to use more advanced commands, right? So which is currently not in scope, but you can write Windows functions and all to find the first 10 values or the nth salary, right? In order to do things like this, we have to go for more advanced commands, right? Or you have to write subqueries. There are different ways of getting it, but not within the scope of this 4-day course, right? Yeah. Rahul has given a command saying, select average salary where department ID in 10, 20, and 30. Yeah, that is fine. This will not solve this case, right? What is Rahul typing? Rahul is saying, select average salary from my EMP, right, where DEP ID in 10, 20, and 30. This will not solve this purpose. What will happen when you execute this command? It will select everybody from department 10, right? So department 10, there are 4 people whose salaries are so much, right? 3 people. And in department 20, there are 3 people with salaries like this. And in department 30, there are 3 people with salaries like this, right? So the average salary will find the average of all of this. It will add up all of this and divide it by the total number 9, right? And it will give you one number. That is not what we want. What do we want? For each department, what is the average? I want to know for department 10, this is the average salary, right? For department 20, this is the average salary. So similarly for all the departments in the company. Okay. So now, how do we do that? If you are asked to do this manually, what would you do? If you are given, let's say you are given an Excel sheet with the department ID and salaries. What will we do manually? First of all, we will collect everybody belonging to department 10. Right? And then we will find the average salary for this group of people and we'll get one value, 1,500. Then we will put together all people belonging to department 20. For this set, we will find the average salary and we will give out one value for this set. So what we are doing is we are grouping the records. We are grouping the records based on the department ID. That's what we are doing. We are grouping the records based on department ID, and then we are applying this function on every group. Right? So this is applied on every group. This is what we want. Right? So this is, this is what we need to do. Right? So all you need to do is you can say select average salary. Right? So, or let me type it. So all I have to say is select the average salary from my EMP, group the records by DEP ID. Right? So now what it will do is, okay, let me select the department ID also so that we can know for which department what is the average. So I'll select DEP ID, right, and average salary. So now what has happened? This will first group the records just like we did, right? If you do manually, whatever we will do, we will group the records together based on the department. So that is what happens first. You group the records based on the department. And then this function, average salary, will be applied on each and every group that is created. Because we have 11 departments, we have 11 groups, and on each group, this average salary has been applied. I hope this is clear. Right? So this is what we are doing. Group the records based on department, and on every group that is created in this way, apply the average salary method and get the corresponding output. Right? So that is what your group by does. Is that clear? Right? I hope the logic that is being applied is clear here. So the main thing that you need to remember is this aggregate salary is being applied on every group that is created. Right? So that is why you are getting for department 90, this is the average. For department 60, this is the average. Right? How to group specific department IDs and not every department ID. You cannot prevent the grouping, right? But you can select only specific groups. So if you want to select, let's say you want to see only for 10, 20, and 30, or you want to see only for 20, 40, and 90, right? If this is the case, you can select specific groups by specifying the having clause, right? Where clause is used to select records, select specific records, whereas the having clause is used to select specific groups. Right? I want to select the value corresponding to this group and this group, for example. Right? So how will I do that? I will say select star from my EMP, group by department ID, but I am only interested in those groups having department ID in, let's say, 40, 50, and 80. Right? So this will give me only these departments. Right? So the having clause can be written the same way like you write your where clause. All conditions are applicable. Only thing is, if you're choosing a particular group, you have to use having. If you're selecting specific records, you have to go for where clause. Right? So these are your grouping functions. Right. So now let us get into the advanced topics. Right. So we will see how to select data from multiple tables. Right. So joins, constraints, these are all very important concepts when it comes to working, and also when you, if at all you are attending some interviews, right? So most interviewers start off with questions from joins onwards. Whatever you have learned till now, it is kind of understood that you need to have. It's like learning the alphabets, right? So we are going to enter into slightly advanced topics. So we will see how to write joins to select from more than one table, right? So till now we have only selected from a single table. So sometimes your data will be available across multiple tables. Let's say on your database, right? So there are two tables. One is called, can you copy paste the previous command? Which one? This one? This command? Okay. Right. All right. So if you look at your database, right? So there are two tables. You have a table called movies, right? And you have a table called members in it, right? So it is like, remember earlier, I think it's still there. There used to be some shops where they have some movie CDs. You can take a membership there and you can rent out some movies, right? So it's something similar. So you have a shop where you have 10 movies, 10 CDs with you, and 8 people have become members in your shop, right? So if you see, some members have already rented some movies. So this person has rented one movie here, right? But in order to see what is this movie, you have to go here. What is this movie? This movie is actually movie ID 1, right? What is movie ID 1? This is Assassin's Creed, right? And it belongs to the animation category. So in order to find out this information, you have to go to a different table and get the details, right? So in cases like this, you can join these two tables together. When you join two tables together, you will have access to all the columns from both tables, right? So you have 3 columns here and you have 4 columns here. When you join these two tables together, you have access to 7 columns. All 7 columns are available in the resultant table that is created when you join two tables together. When I say resultant table, this is a virtual table. It actually doesn't create a separate table, but you can think of it like two tables have been joined together and into one table, right? So we said there are 7 columns. 7 columns will be available to us after you join the two tables, right? But then how do we know how many rows will be available? We know how many columns, right? So how many rows we will talk, it depends upon the type of join that we are going to see. Aditi, why do you say 80? 80 is actually you will get 80 if you do what is known as a cross join, right? Depending upon what type of join it is, you will get different number of records. Okay, so let's see what are the different types of joins. So types of joins, you have what is known as an inner join. You have something called a left join. Then you have a right join. Then you have a cross join. And you have something called a self join. These are the 5 joins that are supported in MySQL, right? Nikhil is asking, will the resultant table be saved as well? No, it will not be saved, right? Tomorrow we will talk about views. If you want, you can create a view on top of it, right? So that can be done. Okay, so these are the different types of joins that are supported in MySQL. If you look at other databases like Oracle and all, it supports something called an outer join, a full outer join. So different databases support some additional type of joins. But we are looking at it from the point of view of MySQL, right? So these are the joins that are supported. So as far as MySQL is concerned, left join and left outer join are the same, right? Right join and right outer join are the same, right? So you don't have a separate type here. So let's see what happens when we do these kind of joins, right? So what happens in an inner join? Let's say you have table T1, and table T2. Right, which is frequently used. There is that cannot be answered, right? All joins are equally important. It depends upon the scenario, right? So when you have table T1 and T2, how many, what will be the resultant number of columns? Will be all columns from both tables, but the number of rows will be decided by the number of common records in both tables. We'll see how to find common records, but how many ever common records are there in both tables, those will be selected, right? If you do a inner join. Yeah, matching records from both tables, right? If you have a left join, you have T1 and T2, right? So if you do a left join, you have to differentiate between a left table and a right table. So if you assume T1 to be the left table, then all records from the left table will be selected, right? And common records from the right table will be selected. This is what happens in a left join. How about a right join? Again, you have to differentiate between left table and right table, right? So T1 is your left table, T2 is your right table, right? And if you do a right join, you will get all the records from the right table and common records or matching records from the left table, right? So let's try it out. So coming to our movies and members, right? Let's say I'm doing an inner join of movies and members, and let's say, okay, I take movies as one table, and I take members as the second table, and I'm going to do a inner join, right? So that means matching records from both tables will be selected. So what do we mean by matching records? Yeah, only matching records will come in the case of inner join, right? So you see whenever you're joining two tables, there should be one column which is common to both tables, right? So there should be a common column connecting two tables. Only then you will be able to join. There should be some relationship, right? If there is no relationship, you cannot just join any table, right? You cannot join the stock market details with your chemistry marks or something. So there should be some kind of relationship between the tables. How do we identify what are common columns? In this example, if you see the value in the movie ID column, right? So this column, this values are actually coming from this column, right? So this ID1 corresponds to the ID1 here. So this is the column that is connecting both, right? So you can think of it like you have this table, and then you have the ID, right? After joining, you will have ID. Yeah, that is right, Sharath. ID. Then you have title from the movies table and the category from the movies table, right? So after doing an inner join, you have access to all the 7 records in the resultant table. So now what are the values that will be available? Only the common values will be available, right? So if you look at the movie ID 1, correspondingly, there is a movie ID 1 here. So that is the value that will come. 1, Assassin's Creed, and category is animation, right? Corresponding to 2, there is a record here. So that will be 2, Real Steel, right? And that is also animation. How about 3? 3 is not there, right? 4 is not there. 5 is here and 5 is here as well. So you will have 5 here, right? So safe. And this is an action movie. And then finally you have 8, not finally. 8 has a corresponding record in both tables. So 8 and deadline. And that is an 18, that is a 18 plus movie. And 10 you have here and 10 you have here. So that is Marley and Me, right? And that is a romance movie. So the resultant table that is created will contain these values, these 5 records and 7 columns, right? It is as if you have a table like this. And from this table, you can select whatever you want, right? Legendary movies, okay. Right, so this is what you will get if you do an inner join, right? I hope you are clear with what we mean by common records or matching records. So this is the resultant table, right? And from this, you can select whatever you want, whichever columns you want. Or if you want to select all the columns, then that is also fine, right? You can select it as if it is all available in a single column. You can give your where clause, right? You can select where ID is greater than 2 or where category is animation. You can give your where clause, right? Anything, but you can imagine that you have a table like this if you do an inner join of movies and members. So what is the syntax to create an inner join? You will select whatever you want, right? So let's say I'm selecting star from movies, inner join, members. And now I have to say what is the common column based on which I have done a join. What is my common column? The movie ID column in the members table and the ID column in the movies table. Right, so this is the thing that is connecting our tables. Right, so the movie ID is equal to ID. This is the connecting condition, right? So this is what you need to specify. So I'm doing an inner join of movies and members based on the ID column and the movie ID column from the 2 tables. Right, so this is the syntax for creating your inner join. So you are selecting from this thing, right? So this is this. Movies inner joined with members based on this condition is this table, right? And from this, you can select whatever you want. You can write your where clause. You can select only title and last name, right? Whatever you want to select out of this table, you can select. Okay. By the way, inner is optional. If you don't specify what type of join, if you just say join, it is understood that it's an inner join. That's the default join, right? So shall we try it? Oops. Okay, let's try it. So I'll just say select. I'll select everything, right? Star from movies, inner join or just join members on ID is equal to movie ID, right? So this gives me the 5 records that we just saw. Okay, so this is your inner join. What happens with the left join? First of all, we have to identify what we want to be the left table and what we want to be the right table, right? Let's say my movies is my left table. and members I choose as my right table. And I want to do a left join. What will be the result? How many columns will be there? Any join you do, you have access to all the columns from both tables. Only difference is the number of rows, right? So if you're doing a left join, all the records from the left table will be selected. How many records are there in the movies table? There are 10 records in your movies table, right? So you will have 10 records in the resultant, and wherever there is a matching record in the members, those values will be populated, right? So your resultant would look something like this. You will have all the values from the left table, which is movies, and from the right table, only matching IDs will be there, matching values will be there, right? So member ID, let's just write it as name. First name, last name, of course, is there, and movie ID, right? So member ID, so corresponding to 1, we have a value. So member ID 1, Alicia has rented movie ID 1. How about movie ID 2? There is a corresponding record. So member ID 2, Don Draper, has rented movie ID 2. Nobody has rented movie ID 3. So you will have null values here. Null and null and null. Nobody has rented movie ID 4. Right? So again, null, null, null. But somebody has rented movie ID 5. Right? So what is 4 also? Okay, the 5 somebody has rented. Who has rented it? Member ID 3, Lissy Moss, has rented movie ID 5. Right? So member ID 3, Lissy Moss, has rented movie ID 5. Right? 6, nobody has rented. 7, nobody has rented. 8 has been rented by somebody. So member ID 4, Eldon, has rented movie ID 8. Nobody has rented 9. Somebody has rented 10. Right? So Jenny Patterson, member ID 5, Jenny has rented movie ID 10. So this will be the resultant table that is created when you do a left join of movies and members, where you're considering movies as the left table, right, and members as the right table. Fine, right? So this will be the resultant table. And from this, you can select whatever you want. Right? So writing the query is very, very simple. All you have to do is you have to replace inner join with the left join. Right? So you will just say, instead of inner join, specify left join. And how do we know which table is the left table and which table is the right table? The one that you specify first is the left. Right? So this is your left table and this is the right table. Or another way to look at it is, if you look at the join keyword, irrespective of what join it is, the table to the left of it is the left table and the table to the right of it is the right table. Even if you're doing a right join, right? It doesn't matter what join. You look to the left of the join, that is the first table, that will be the left table. The one to the right will be the right table. Right? So in our case, movies is the left table, and that is why all the records from movies have been selected. Right? So let's try this. I've just changed inner join to left join. And if you execute this, you can see this is what we saw. Right? This is what we had written down. For these records, there are no corresponding matching values, so you get null values. Right? I hope this is clear. Left join. What will happen if you do a right join? How many records will I get? Why 5 records? So when you do right join, right, I hope you remember the number of records in both tables. You select from movies and the members, right? So I am going to do a right join with movies as the left table and members as the right table. right? So this is movies and members, and we are going to do a right join, right? So when you do a right join, all the records from the right table will be selected. So that means all records from the movie table will, sorry, members table will be selected. If there are any matching values, the corresponding ones will, corresponding ones from the right table, the left table will be selected, right? So that means we will have 8 records in the output. Corresponding to these, we will have some result, right? You will have movie ID 1, Assassin's Creed, and something, right? Movie ID 2, Real Steel, you will have movie ID 5, Safe, and movie ID 8, Deadline, right? And movie ID 10, Marley and Me. But corresponding to this, you will not have any records, right? Because you don't have any movie IDs. So these are the 8 records that will be selected if you do a right join, right? Again, writing a right join is very simple. Just replace your left join with the right join, and you will get the right join. So we will just replace this with right. Right. So totally you get 8 rows. We are seeing all the members irrespective of whether they have rented any movie or not. Right. And for those records which have matching values in the movies table, those values are available. For others, we see null values. Right. Yeah. 10, ID 9 and 10 is null. What? I hope this is clear, right? How a left join, right join, and all works. Sumit, yeah, yes. Sumit is asking, can we join more than 2 tables? Yes, it is possible, right? But not within the scope of these sessions, right? All right. So next we'll see cross join, which is very simple, right? Cross join is called the Cartesian product. So in the case of cross join, only in the case of cross join, we don't need any common records, right? You can connect any table to any table, right? So let's say you have table 1 with 3 records in it, and you have table 2 with 3 records in it. Cross join will take this record, connect it to all 3 records in the second table. Then it will take this record, second record from the first table, and it will connect it to all 3 records in the second table. Then it will take the third record, connect it to all the records in the third table, right? So this is called a Cartesian product. There is some question. Yeah, actually, yes. This is Manohar, I don't get your question. This is all done with syntax only. I'm not sure what you mean, but I think Rahul's question, I think that is what he's asking. See, one thing I wanted to tell you is, if you have something, right? If I say T1 left join T2, and I say T2 right join T1, right? What will be the result in both cases? In these 2 cases, what will be the result? So when I say T1 left join T2, what is my left table? Left table is T1, right table is T2, right? So T1 is my left table, T2 is my right table, right? So now what will be the result? All the records from the left table will be selected, right? And only common records from the right table will be selected, right? So all T1 plus common from T2. How about this one? When I say T2 right join T1, which is the left table? T2 is the left table. T1 is the right table, right? So T2 is my left table and T1 is my right table. And I'm going to do a right join. So that means everything from the right table will be selected, right? And common records from the left table will be selected, right? So again, all from T2 from T1 plus common from T2, right? So this means, see, the resultant is the same, whether I say T1 left join T2 or T2 right join T1, the end result is the same, right? So these two are equivalent. So that means anything that you write with right join can be rewritten using your left join. Is there a problem with the audio? Are you able to hear? Yeah, Manohar, everything is done with syntax only, right? We can hear? Okay, fine, fine. Somebody is saying they are facing a problem. Okay, fine. I hope this is clear, right? So you can, it's not necessary to use right join, right? Anything that you do with right join, you can do with left join only. So yeah, Manohar, yeah, fine. Right, so these two are equivalent. So you can work with left join. People prefer to work with left join because it's a little bit more intuitive compared to the right join, right? So you can forget it. So you can use any one of these to get the same result. Okay. All right. So now coming to cross join, right? Cross join is what we call the Cartesian product. So how many resultant records do we have here? We have 3 records in the left table, right? And we have 3 records in the right table. And every record in the left table is connected to every record in the right table, right? So this is a 3 into 3. So you get 9 records, right? So that is your Cartesian product. So if you have 10 records in table 1 and 5 records in table 2, right? What will be the resultant? 10 into 5. So this is 50 records, right? So this is what what we mean by Cartesian product. So we'll see an example, right? Like I said, it's not necessary to have a common column, right? We are just joining 2 tables together. So on your database, there is a table called meals star from meals and star from drinks, right? So now I want to create a menu, right? By taking, so this connection, this type of join is called a cross join, right? So this is called a cross join. So this is also called a Cartesian product, right? Sorry, Rahul, I didn't get your question. What was the question here? Rahul, I think others are able to hear properly. So that's what I checked. So thanks, Jessica. I'm glad that you're enjoying the sessions. All right, let's continue with this, right? So let's say you want to create a menu out of this. That is, you want to have omelette and tea. You should be able to have omelette and coffee and omelette and Pepsi, right? So similarly, sausage and tea, coffee, Pepsi. All possible combinations, all combos we want to create. So only thing I have to do is I will say select meal name, right? Drink name from meals cross joined drinks, right? Remember, we don't need to have any common column here, right? So I don't have to say on what condition. So this will give me all possible combinations, right? I can have pancake, sausage and omelette with tea, pancake, sausage and omelette with coffee, pancake, sausage and omelette with Pepsi, right? But in this particular case, we have an issue. Because if you see the meals table and the drinks table, both of them have a column called rate, right? So if you select rate from this, if you want to see the rates from a drink table, for example, you cannot do this because it will say, I don't know what is rate, right? So from where do you want me to get the rate? Because meals table has a rate column, drinks table also has a rate column. So it will say rate in the field list is ambiguous, right? So I don't know from where I need to fetch it. So one thing that you can do is you can prefix your column names with the table names. If I say meals.rate, right? So now MySQL knows that rate from the meals column is what we are interested in, right? So this will get you the rate from the meals column. Similarly, I can also get drinks.rate, right? So this will know that it has to fetch the rate column from the drinks table, right? Right. So this is how you write your cross joins, right? Coming to this prefixing, right? So the prefixing, see, as a matter of practice, it is always good practice to prefix your column names with the table names when you are writing a join, right? Irrespective of whether there is a conflict or not, it's always good practice because here, see, you can see it's a very small table. So you can easily remember that the meal name is probably coming from meals and drink name is probably coming from drinks, right? But in real time, you will have tables like, let's say, even table names will be very big, right? So you might have something called transactions underscore first underscore quarter underscore 2020. So this could be one table, right? And the second table that you're joining could be transactions underscore second underscore quarter underscore 2020, right? So there will be multiple columns inside this. There will be different columns inside it. So anybody looking at the join query, right, will not be able to immediately understand which columns are coming from which table, right? It's always good practice to prefix the column names, probably the sales from this and the sales column from this table, right? Always it's good practice to prefix. But again, when you have table names like this, big table names, it's a big problem, right? You have to every time attach such a big name to your column names. And if you're selecting some 20, 30 columns, your query will look quite horrible actually. So to avoid that, what we can do is you can have an alias name for tables as well. Remember, we had an alias name for columns, right? So similarly, for tables also, you can give an alias name. Probably you can call it TF20. And this could be TS20, right? So the transaction for the second quarter of 2020, transaction for the first quarter of 2020. So you can just write it as TF20.sales, comma TS20.sales. So now it serves our purpose. We know this comes from this table and this comes from this table, right? And we are not typing such a big table name every time, right? So always when you're writing joins, the best practice is to use an alias for tables, right? And prefix all column names, whether you have ambiguity or not. All column names with the table aliases, right? So if you rewrite this query using a table alias, how will this look like? I can say, let's say I give an alias name of D, any shortened name, right? So I'll call meals as M and drinks as D, right? So then I can say M dot meal name, D dot drink name, M dot rate, D dot rate, right? From meals as M and drinks as D, right? So shall we type it? So I'll say select M dot meal name, D dot drink name, M dot rate, and D dot rate from meals as M cross join, right? Drinks as D. There is no difference in the result, right? Only thing is your query becomes much more readable. So this is a good practice that you should follow whenever you're writing your joins, right? So I would suggest that you try doing this, right? Giving a alias name and prefixing the column names. Rewrite the left join that we had written. I don't know if you remember the left join, but you can watch the video, right? And try to rewrite your left join using alias names for tables and prefixes for column names, right? Otherwise, tomorrow anyway, we will see that. The last join that is left out is called the self join, which could be a little complex, right? Because we will be joining a table to itself, right? So that we will do tomorrow, right? So let me stop for now. Hopefully you were able to understand the concepts that we looked at today, right? Especially joins, because they are quite important. Okay. So yeah, thanks, Ashutosh. Fine then, meet you all tomorrow. Tomorrow will be our last session, right? And we will